Okay, we're going to start with, again, there's 4 situations we're going to talk about. I want to start with the one in which case the vertex lies on the circle itself. Okay, there's 2 scenarios in which this is going to happen. Inscribed angles. Okay, so here's a case where the vertex lies on the circle and the sides are chords of the circle. But then it's also going to fall, or it's also going to exist in an angle whose vertex lies on the circle and whose sides are tangent segment. And a secant segment. Okay, so that's this second, the darker green angle. This has a tangent segment and a secant segment that form the sides of that angle. Okay, on either of these cases, the following relationship holds true. The angle is equal to 1/2 the intercepted arc. Okay, so what that means is if this intercepted arc, which I'll call M, and I'll call this angles 1 and 2. If we have this intercepted arc M, then the measure of angle 1 is going to equal 1/2 of M. The measure of angle 2 also has its vertex on the circle, so it's going to equal 1/2 the intercepted arc, 1/2 of M. Okay, now not only does this relationship hold true, but the kind of reciprocal relationship does as well. If we wanted to solve for the intercepted arc, if the angle is half the intercepted arc, then the intercepted arc is going to be what compared to the angle? Double the angle. And so the intercepted arc is equal to 2 times the angle. So here, if we wanted to find M, we could either say M is equal to 2 times the measure of angle 1, or M is equal to 2 times the measure of angle 2. Either of those relationships hold true. Right, so this is a pretty standard basic relationship. You are going to see it come up a number of different times in the problems that you're going to be working with. And so let's take a look at how some of the basic calculations involving these angle and arc measures will look. And see if you can answer these 2 questions. Find M for each of the diagrams below. I'll go back here in just a second. All right, up on the board is the other screen. On your screen is the current example. If you need to go back to that other slide later, I'll push it out to you at that time. All right, so this is real straightforward. If this inscribed angle is 50 degrees, what does this intercepted arc have to be? 100, double the inscribed angle. And if this angle here, angle UTV, is 60 degrees, what does that mean its intercepted arc is going to be? Double that, or 120. Good. Questions on those problems? All right, let's take a look at the other direction if you're given the intercepted arcs. All right, again, this is pretty straightforward. X is going to equal half of its intercepted arc, so it'll be 40 degrees. And finally, the X on the second example, half of its intercepted arc is going to be 75 degrees. Okay, questions on any of those? Again, this is a pretty basic concept.